So today we are going to be answering this question related to figuring out the future value of geometric progression, also known as a geometric gradient. It says a person decides to save $350 at the end of each month that will increase 10% each month. So, first month they're going to set aside $350, then $350 plus 10%, and then the next month $350 plus 10% plus another 10%, and so on, right? And so they would like us to find the amount saved after 2 years in a bank that is paying 7% annual interest compounded monthly. All right, so what we need to first do is we need to write down what is given. So, first, what is the annuity that is being set aside each month initially? That initial annuity is $350. Now, what is the gradient value? That's also important, right? We need to know how much is this increasing each month, and it's increasing by 10% per month, so that's 0.1. Then we need to know the n, the number of payments overall made, right? The number, which is also going to be the number of compounding periods, presumably as well, which is going to be 24 because this is happening every month for 2 years, so that's 24 months, therefore 24 compounding periods and 24 payments as well there. And then we have I, which is the interest rate. In this case, we're doing this monthly, right? This is a monthly endeavor where the person makes a payment monthly, they are increasing monthly, and they are also we are also compounding monthly as well. So we need to find the monthly interest rate. So therefore, it's going to be the yearly interest rate, which is 7%, divided by 12 for 12 months in the year. And let's figure out what that is. If we type that in our calculator, I'm going to get 0.0058 and then 3 repeating. So there we go. So now all we have to do is we have to plug in those numbers into our future value equation over here. So the future value, therefore, is equal to 350 times 1.0, or not 1.01, sorry, 1.1 to the power of 24 minus 1.00583 repeating to the power of 24 as well, all over 1.1 minus 1.00583 repeating. Okay, so here's how we're going to figure it out. First, I'm going to do 1.1 to the power of 24, it equals minus bracket 1.00583 repeating to the power of 24, hit end bracket equals again, divided by, in brackets, 1.1 minus 1.00583 repeating, end bracket equals, and then multiply that by 350, and I'm getting $32,336.01. So therefore, if this person decides to continue to do this, they will end up with $32,336.01. Now, this might seem like, oh, well, that's a lot of money. They're only setting aside $350. But here's the thing, they're increasing that by 10% every time, meaning that their final payment to this, right, their payments are going up each time. Their final payment is going to be $350 times 1.1 to the power of 24, right? Because they're going to have done this 24 times. And that is close to, that is over $3,000 just in that last payment there. And so whenever we have payments that are increasing by a certain percentage each month, that really, really starts to stack up quite quickly. And so that is the reason why we see such a large number, even though presumably it looks like, oh, we're only setting aside $350. That doesn't seem like all that much in comparison. This is the reason why that's the case. As always, if you have any questions, feel free to leave those in the comment section, and we'll see you for the next one.